For the Maths GCSE, the first section is with numbers and number systems, and we're starting with simplifying ratios. So it's oftentimes that you see problems like this, which we're used to simplifying ratios in other subjects that we've learned within maths. But one thing to look out for is always to check to see if you're in the same units. So that'd be what I would do first, is I would convert both of these into grams. So as there are 1,000 kilos in a gram, or 1,000 grams in a kilogram, sorry, that means we have 3,000 grams to 840. And then by simplifying, I'm going to divide both by 10 to give me 300 to 84. And then as these digits add up to 12, I know it's divisible by 3. So I'm going to make that 100 to 28. And again, let's see, I know that 4 go into this. So that is 25 to 7. And I can't simplify any further. So this is as simple as it gets, and these are now also in the same units of grams. So our answer is 25 to 7 is our simplified version. So you're going to be seeing some problems like that in the first exercise to simplify ratios. So next we're going to work out a percentage of a given amount. Again, this should be revision. Always good practice in these is before I go over each example is to pause the video and attempt the work yourself. So for this, we are going to do 43% of 5,680, and I'm going to convert that to a decimal of 0.43 times 5680, and we can go ahead and do that multiplication, and in doing so, we will get 2,442.4. As there's no units on the 5,680, there's no units needed for this solution. This next one is also dealing with percentage, but it wants us to increase by a percentage. So we're going to work out our multiplier. Multipliers we're increasing is that we're going to keep all 100% at the 540 and then increase that 100% by 17.5. So I will do 540 times 117.5%, because it keeps all 100% and adds 17.5%. As a decimal, that would be 1.175. And when doing that calculation, we then get 634.5. This next one is dealing with fractions, and you have a few calculations to do. So as always, if we have more than one calculation, we follow BIDMAS, our order of operations, which means we're going to take care of the dividing part first. Now when we divide by a fraction, we want to multiply by the reciprocal. So I'm going to keep the 9/10 the same, minus. The first fraction stays the same. It changes to multiplication. And the reciprocal means you flip the spots of the numerator and the denominator. We're now going to go ahead and do our multiplication because it becomes before subtraction as well. So I have 9/10 minus 2 times 7 and 5 times 6. Now one thing that I'm going to do is I'm going to go ahead and simplify this fraction now because it'll help me from making bigger numbers that I have to simplify later, especially since it says without a calculator. 2 goes into both 2 and 6, so I can change that by dividing them both by 2, and I now have 1/5 over 7/3. So now I'm going to go ahead and do this multiplication. 1 times 7 is 7, 5 times 3 is 15. To complete this up, I'm going to get my lowest common multiple of my denominators. So I'm going to multiply by 3 over 3 to keep an equivalent fraction, and then 2 over 2, again to keep that fraction equivalent. So we'll end up with 27 over 30 minus 14 over 30, which gives us an end solution of 13 over 30. This next one is a ratio problem, but you're dealing with having two different ratios. It says given the ratio x to y is 5 to 3 and y to z is 4 to 7, work out the ratio x to z in simplest forms. So what we need to do here, well, try it first if you haven't yet, is get the y components in both cases equivalent, so that way then the x and z can be compared directly. So looking at the y components, 3 for the first one and 4 for the second one, I could turn them both into 12 because that's the lowest common multiple. So I'm going to say x to y is, and if I'm turning that 3 into a 12, it's because I multiplied it by 4. So I'm going to do the same thing to the 5. And I'm going to say an equivalent ratio would be 20 to 12. Then I'm going to do the same thing to y to z. 4 becomes 12, which means I tripled it. So I'm going to triple the 7 and say it's 21. Now that both of them have a y value of 12, I can write it as a single ratio, x to y to z is 20 to 12 to 21. Now they didn't want me to have this in terms of x to y to z. They just want x to z. So I'm going to take out the y component, and I'll say there's 20 x's for every 21 z's. And there's no common factor other than 1, so that is it in its simplest form. This problem wants us to do the calculations to 3 significant figures. So this is definitely going to need our calculator. So I'm going to go ahead and bring mine on here. And it says, let me see if I can make that a little bit brighter for us. Hopefully you can see that a bit better now. 3.76 is in a fraction, go back up, times 34, and divide by 78.4 times 980. And it gives me as a decimal, so I'm going to hit the S to D button, which will turn it into a decimal. Now this decimal value that it gives me is in standard form. So it says that it is 1.66389046 times 10 to the negative 3. Now a common error here is people just write 1.66 and ignore the times 10 piece. So you could either give your answer as 1.66, because that's 3 significant figures, but you must have the standard form knowledge that it's times 10 to the negative 3. Or you can go ahead and convert that as that is 0.00166. Remember, you can't start significant figures with zeros. So this is still 1, 2, 3 significant figures. Now that we've finished these 6 examples, go ahead and try exercise 1A from your Further Maths book. Do make sure that you mark your work from the back. And if you have any questions or any that you'd like me to go through, please make sure to comment on it.